So the last section talks about specifically zeros of polynomials, and I want to make sure that we make this connection between zeros and particularly factors, because if you have something that's a zero of a polynomial, it's also in a way going to have that specific factor that pairs with it. It's not going to be identical, but we need to make that distinction because we're going to be talking about both of those in this section. But I want to start with talking about what's called the fundamental theorem of algebra. And what the fundamental theorem of algebra boils down to is that if you have any nth degree polynomial, doesn't matter what it looks like. There's two things that we can say about it. It has n solutions, and a response from this theorem. This isn't from the theorem, but also you can something you can say from this is the fact that it has n linear factors. Okay? So if you look at a second degree equation, it doesn't matter what it looks like. It can be something that looks like this. That's going to have two linear factors and it's going to have two solutions because it's a degree 2 polynomial. That's what this theorem says. Now we're also going to talk about something that allows us to use this theorem and help us with creating specifically some functions based on these criteria. But we need to make sure that whatever the degree of the polynomial is, that's how many solutions there are going to be. They can be both real or complex. Now, there is something that's going to help us find zeros if we don't necessarily know how to find them. So I'm going to write an nth degree polynomial, and I'm not going to write the whole thing out, but I'm just going to say that this is my leading coefficient, and this is my constant term. So what the rational zero test says is that if you have any polynomial that is an nth degree polynomial, the possible rational solutions are as follows. They are either plus or minus any factors of z, this being your constant term, all divided by the plus or minus factors of your leading coefficient. Now, this is a very hard concept for people to understand. So when we talk about examples, you really have to look and see what numbers I'm using and why I'm using them. So when you're using this test, we have these rational zeros that we have to look for. So what we need to know is that the leading coefficient is equal to 1. The constant term is also equal to 1. So this is going to be a very easy problem to find and list all the rational zeros. So the possible rational zeros are plus or minus the factors of the constant term, which is just 1, and the plus or minus factors of the leading coefficient, which are also 1, or which is also 1. So this makes this very easy for us. So this is only plus or minus 1. when you see this one down here, you're going to see a different combination. But all we have to check now is if 1 or negative 1 are zeros of this function. So I'm going to use synthetic division and check. So I'm going to write this down. I didn't get a remainder of 0. So it's not a 0. So this is not a 0. So now I'm going to check the other one. I'm going to check a positive 1. So 1, 0, 1, and 1. I didn't get a 0 here. So these are neither zeros of this. So if it's not going to give us a remainder of 0, they're not zeros of this. And we could have checked both of these by plugging them in. But because neither of them were zeros, this function has no rational zeros. Has no rational zeros. Okay? There's no possible rational zeros for this. Now, it's going to work a little bit differently because we have a lot more to check for this one. It doesn't even matter if it's plus or minus. What we have to realize is that we have to deal with plus or minus all the factors of 6 over plus or minus all the factors. I chose 6 because it was the constant of 1. So I have to look at all the possible factors for this. So it's going to be 6, negative 6, 3, negative 3, 2, negative 2, 1, negative 1. And all of these would be divided by every single factor of this. But since it's just plus or minus 1, I'm dealing with all of the positives and all of the negatives. So I have 8 possible zeros that I can check. So what I'm going to do is I'm going to start picking them one by one. So 0, then this becomes a 6. You can already start to see that this is not going to be one of them. So this one didn't work. Now I'm going to do the exact same thing with negative 6 and see what happens. You can start to see this one as well is not going to work out either. So that one's not going to work either. So that didn't give us a remainder of 0. So now I'm going to check 3. I don't know why it's rejecting some of the things I write. So I still haven't gotten there yet. I've tested 3 of the 8. So I'm going to pick another one. So I still haven't found it. I've gone through half of the possible choices. We've gone through this one, this one, this one, and this one. Now I'm going to deal with some smaller numbers and see what happens. And as you can see here, I finally got a 0. I finally got one. I picked one out. So 2 is one of them. Okay, so because 2 is a 0, that means that the expression x minus 2 is a factor. So I'm going to write that below it. This is the 0. This is the factor. So now, rather than have to go through all of them, I can check these last 3 with this one here. Nope, that one's not going to work. So now I'm running out of space. Can already tell that this one is not going to work as well. So my last one, my only other possible choice is -1. I found the other possible 0. So my 2 zeros are 2 and -1. Those are my 2 rational zeros. So that means my 2 linear factors that I found for this are x minus 2 and x plus 1. Okay? Now, you might ask, well, what does that mean about the other ones? It's a 4th degree expression. I should have 4 solutions. Well, the only thing is that the other 2 are not real number or non-rational number solutions. And we're going to talk about how you find those in the next part of this right here. So with this problem, I'm going to first talk about all the possibilities for the zeros for this. So it's plus or minus all the factors of 3. So it's going to be 3, -3, 1, -1. From here, we have to list all the factors of this one as well, which are 2 and 1. So every one of these has to be divided by 2. And every single one of these has to be divided by 1 as well. So again, I have 8 different zeros that I can check. And I'm going to start with the smaller numbers here and see if I can find the zeros before I go into the fractions. So I want to avoid trying to find fractional zeros. So I'm going to check these first. And that'll be the start. That'll be the start of the next video.